Good day, everyone, and welcome to our first lesson in ENV 111, Engineering and Sustainable Development. In this lesson, expect that we will be heavily discussing about how do we balance our development interests with that of the environmental interests, and it centers on sustainability. So let's begin. Before we go to the concept of sustainability, let's first take a look at some graphs to describe how are we living these days. This first graph details our world population trend over the last 12,000 years. We start at about 10,000 BCE, wherein our population is just very, very little compared to what it is now. And at about the start of 1700, wherein our population is about 600 million, that population suddenly began skyrocketing. It began to exhibit exponential growth. So from 1700s, 320 years later, we are now 7.7 billion strong and counting. So this gives you a scale of how many people really are living on Earth compared to other times. We cannot only talk about the entire world population. In order to get this into perspective, we have to talk about population density. So population density is described as the number of people living on a certain area divided by the total land area of that country. So this is a map of the world wherein there is a gradient in effect, wherein the light colors have low densities or low population densities, while the darker green colors have higher densities. And you see that majority of the high density countries are in Asia. That's China, India, Japan, the Philippines, Vietnam, etc. No? And you can also see that some of the European countries are getting more and more denser, as well as some of the African countries along the equatorial belt. This map gives you an idea of the distribution of the people around the world. In general, the people are so this gives you an idea of the distribution of people around the world. We are living on an increasingly dense landscape. What does population density have to do with our topic today? We will be dealing first with urbanization. Urbanization is described as the rate at which people are migrating toward urban centers of a country or of the world. So we see here the trend of the urban population of the world from 1960 up to 2017. You see that in 1960, there are more people living in rural areas than in urban areas. But as our technology progressed and as more work is being required in the urban areas, more and more people started to migrate to urban areas until at some point, we now have more people living in urban areas than in rural areas. So what's the problem with that? Isn't it the goal of our continuous development to eventually live in urban areas wherein all of our needs are being met? Well, the problem is, as an urbanizing world, we need a lot of resources and a lot of materials. So here are the biggest needs of an urbanizing world. First, of course, housing and infrastructure. How do you plan to house the ever-growing population of the world? Of course, we also need water and sanitation, and it has to be structured because in urban areas, if you don't consider well-structured sanitation, then there will be big problems. Another is energy. So energy is what fuels our ever-developing world. And the last but not the least is food. How do you feed an ever-growing population? These are the most important needs of our population as it keeps on getting urbanized. However, there's a problem with this urbanization. What happens as we progress is us consumers are steadily demanding resources from our environments. So normally that's not a problem. However, our waste is also directly impacting the environment where our resources are coming from. So you see here, this is a vicious cycle wherein the consumers require their resources from the environments from which they also dispose their waste. So what happens here is as our waste continues to degrade the environment, our resources would be harder and harder to come by. So this is what we are trying to solve. We want development. However, we don't want the wastes of our development to pollute our pool of resources. With that, let's talk a bit about the tragedy of the commons. This is a hypothetical piece that is commonly discussed in topics of ecology. So, what is the tragedy of the commons? A simple description of the tragedy of the commons is that people sharing a common resource will also share its exhaustion. This is especially true in closed places. For example, in islands, wherein the resources are limited and are shared by the entire population of the island. The selfish act of an individual on a shared resource leads to the suffering of everyone sharing the resource. Let's say, for example, that there are 10 people living on an island with finite resources, and one of them is very greedy and he hoards much of the resources. They would all suffer because the action of the one greedy person is now exhausting all of the resources that is shared by the entire population. Another example is we can demonstrate it through a parcel of land that is being grazed by sheep. So you see here that the use of commons is below the carrying capacity of the land. That means that the sheep are eating what the land can replenish. So that makes it a sustainable system wherein the sheep would eat grass all day long, but then the grass would just regrow the next day so that the sheep could eat again. However, that only works if you have a small number of sheep. If you start to increase the number of sheep, what happens is that the sheep are now grazing more and are depleting the resources faster than usual. So the land cannot keep up with the depletion of the resources. And if you further increase the amount of sheep on that parcel of land, the resources would start to degrade very, very fast. And what happens is all of the sheep would now go hungry because they would no longer have a source of food. Okay? So that is the tragedy of the commons. This is normally applied in a larger scale, for example, a country or even a continent sharing its resources. Since we have already mentioned the carrying capacity, let's discuss it here. What is the carrying capacity? We define the carrying capacity as the maximum population a given environment can sustain. So based on our previous example, let's say for instance that a grazing field can only sustainably carry 3 sheeps. So if you exceed 3 sheeps on that grazing area, then you are exceeding the carrying capacity of the environment. That means that it can no longer sustain that population. This is a graph of population versus time, and it shows you the carrying capacity. So the graphs here show that as time progresses and as development progresses, the population can increase because we are not yet at our carrying capacity. However, there will come a point wherein we are using as much resource as our environments can give, and that leads to an overshoot wherein we are exceeding the amount of resources that the environments can provide. In short, we are exceeding its carrying capacity. So what happens with a population that has overshot? Of course, since you are using more resources that can be provided, that means that you are at a resource deficit, so some of the population will suffer. You see for this pink graph that after the overshoot, some of the population suffers, so the population dwindles up to a level below the carrying capacity of the environment, and then it again overshoots and dwindles and overshoots and dwindles, and so on and so forth. So this is nature's way of controlling the population of a certain species by controlling the amount of resources that it can give. However, for humans, we are more intelligent than other species, so we have learned to extract more and more resources from our environments. We have learned to process materials and turn them into other useful materials. The population extracts resources at a particular rate. If the carrying capacity is exceeded, the increased rate of resource extraction would decrease the ability of the resources to regenerate. Since humans are very intelligent, we can extract more and more resources out of very limited resources. What happens now is our carrying capacity starts to decrease because we are degrading the environment by getting more than what we need. So this is again our population curve. Through exponential growth, we overshoot our carrying capacity. There would be some that would die off, and then it would overshoot again and die off and overshoot again. But take a look at the carrying capacity curve. It's no longer constant. It starts to decrease after you have overshot the carrying capacity by a few times. That means that the environment is now degrading and can now provide less and less resources to the population. Does this curve look familiar? The exponential growth of the population? Well, that looks familiar because that is our current population growth. We are currently on the exponential phase of our growth. If you take a look at this graph, historical data indicates that last year in 2019, we are at 7.7 billion. So this is still our exponential growth curve. But if you take a look at our growth rate, that is the pink line here, our peak growth rate was in 1968, that is 2.1%. And since then, our growth rate starts to decline. Now, is this growth rate a sign that we have reached our peak? And is this a sign of the degrading carrying capacity of the Earth? Well, this plays into several factors such as education, birth control, birth rate, death rate, fertility rate, etc. There's a lot of factors that influences this growth rate. But take a look at the future projections. So beyond 2019, from 2019 up to 2050 up to 2100, you see that our exponential growth is no longer maintained. It starts to taper off. This is what we call logistic growth, wherein it's not always exponential growth. There will come a time wherein our population would stop its rapid growth, and apparently, based on these projections, it will happen in the near future. So what happens beyond 2100? No one can say, but it's very possible that there will be a population collapse wherein the resources of the earth would no longer be enough to support about 10.9 billion people beyond 2100. Since we have mentioned about overshoot in carrying capacity, there is a concept that's called Earth Overshoot Day. So this is a very powerful concept. The Earth Overshoot Day is the hypothetical date of the year wherein the world population have already exhausted the available resources that our planet can generate in a year. Basically, Earth Overshoot Day is like your budget. Let's say, for example, you were given 10,000 pesos for 1 week and you have already spent your 10,000 pesos as early as Thursday. So that is Earth Overshoot Day. If you take a look at this data, back in 1990, our Earth Overshoot Day is December 7. That means that we have exhausted our budget for 1990 at December 7. So it's towards the end of the year. But what's happening as time progresses is that Earth Overshoot Day becomes earlier and earlier, such that in 2018, our Earth Overshoot Day is August 1. So what does that mean? That means that our entire budget for the year of 2018 has already been spent as early as August 1. And that is just 2/3 of the year. Okay? That means that we are already overshooting its carrying capacity. This year, Earth Overshoot Day falls on August 22. That is actually an improvement from 2018, which is August 1. This pushback to a later date is attributed to the COVID-19 pandemic, wherein people all over the world largely stayed indoors. So us staying indoors have a very big impact on the utilization of the resources. Okay? But this temporary pushback is not enough for us to offset our overshoot on the resources. So there has to be other ways that we can do to prevent Earth Overshoot Day becoming earlier and earlier every year. Based on current calculations, our population currently requires 1.6 Earths to sustain its needs. Ideally, this number should be 1 because realistically, we only have one planet to use. We need to find ways on how we can continue development but still not overshoot the amount of resources our planets could provide. So this brings us to the competition between the need for urbanization while protecting our environments. When people hear about environmental protection, they instinctively think about not building houses over forests or halting the use of fossil fuels. Environmental protection has a negative connotation in terms of development. However, in a highly urbanizing world, a balance must be found between development and environmental protection because you still need to provide for the population, so we cannot stop development. However, we also cannot sacrifice our environment. Too much development would deteriorate the environment. However, too strict conventional environmental protection could hamper development. Take note that I have used the term conventional environmental protection because that differs from our goal today. Our goal today is to practice sustainable development. Sustainable development is anchored on the idea of sustainability, and we define sustainability as the ability to provide for the needs of the current generation without affecting the ability of the future generations to provide for themselves. So that means that we are not exploiting our resources to the point that they cannot regenerate for the next generations. It's what we do with our current resources that matters. So, sustainable development is also centered around mindful and efficient use of resources. That means minimizing wastes, optimizing processes such that they use less materials and less energy. So while we are talking about sustainability, let's discuss about its three dimensions. We have three dimensions of sustainability, which all needs to be maintained in order for us to call it true sustainability. We have social, environmental, and economic. Social pertaining to the population, environmental pertaining to our environments, and economic pertaining to our economy. You see that this is a Venn diagram wherein there are three intersections between two of those dimensions. The intersection between environmental and social sustainability is livable, meaning we are giving the bare minimum standards for people to live without damaging the environment. The intersection between social and economic is equitable, meaning that the economic benefits over a certain project is distributed across the entire population, meaning all would benefit. The intersection between environmental and economic is feasible, meaning a certain project would both be economically and environmentally friendly. However, what we are shooting for is the intersection of those three dimensions, and that is what true sustainability is all about. We are balancing the interests of the population, the economy, and the environment. We have several tools that we can use in order for us to practice sustainable development, and one of those is life cycle thinking. Life cycle thinking is centered around the idea that our resources are finite, so we need to find ways on how we could continuously use those resources. We must consider the entire life cycle of a product from extraction of raw materials to its final disposal. So when you advance to the course industrial waste management, we will go back to this life cycle thinking and we will be performing life cycle analysis. In a life cycle analysis, you are considering all of the material and energy use and all of the wastes being produced over the entire production cycle, over the entire life cycle of the product. So from the extraction of resources, from the processing to the distribution to the end user, and even to the final disposal of the product. So that entire map gives you an idea of how much waste is really involved in the use and manufacture of that particular material. Finally, life cycle thinking promotes recycling as a way to slow down the rate of use of fresh resources. If you take a look at this diagram here, the production and the use of the materials includes the extraction of raw materials from the natural resources. However, this cycle does not stop with disposal. You see that after disposal, we still have recovery and we still have recycling of materials and components. So what this life cycle thinking does is we are minimizing the amount of fresh resources being extracted because of recycling, and we are also minimizing the amount of the waste that needs to be disposed because also of recycling. We will be tackling more about life cycle assessment in industrial waste management. Another tool that we can use for sustainable development is sustainable design. So sustainable design pertains to structures and materials designed to last and survive repeated use. So this might pertain to buildings, but this could also pertain to products. Sustainable design also centers on the optimized use of materials, meaning that we only use enough material such that your end product would still be durable and still be optimal for repeated use. And sustainable design is design with reusability and recyclability in mind. A very good example of this is the sustainable design of houses and buildings that uses passive methods for heating or cooling spaces depending on where you live. So if you live in countries with cold climates, that would be passive heating using the sun. And if you're living in tropical countries like the Philippines, that is the passive cooling using vents. Okay? So this house shows both passive heating through the sun and passive cooling through vents. Sustainable design is also applied in food packaging materials such that we are using more environmentally friendly substances and we are using less packaging for certain materials. So this could be applied in a lot of other materials. Another guide or another virtue that we can go by is sustainable consumption and production. This pertains to the food we eat and the other materials that we use as consumers. This is relevant because around 30 to 40% of the food that we produce is just being wasted. That's a very big amount that's just going to waste. That waste is coming from production, distribution, retailing, and even up to the house level. So eliminating food waste would be one step toward true sustainability. We also want to lower food miles. Lowering food miles means that we are consuming and producing locally, meaning the produce of a certain place would be consumed very, very near that place. So we don't have to transport the food thousands of miles to reach its destination. Awareness on the carbon footprint of food. This also involves food miles because if you are consuming food that has been grown in a very, very far land and it has been transported to you, that means that that food has a very large carbon footprint because of the transportation. Another thing on the awareness on the carbon footprint of food is a concept that we call the feed conversion ratio. The feed conversion ratio tells us how many kilograms of feed do you need to give an animal in order for it to produce 1 kilogram of edible meat. And if you take a look at this chart, beef has a feed conversion ratio of 31.7. This means that we need to give 31.7 kilograms of grains or of feed to beef in order for you to get 1 kilogram of beef. And that's placing a very big pressure on the land from which we grow what we feed to the cows. And the last concept is sustainable agriculture and restorative soil use. Because in conventional agriculture, the soil has been degraded so much that we have to give it a very big amount of input to produce our food. So these are just some ways on how our consumption can be sustainable. Next is renewable energy. This should not be a surprise to you. Renewable energy should be our future. It affects all the dimensions of sustainability, social, environmental, and economical. And renewable energy is a centerpiece for creating a future that is dependent on clean energy. However, renewable energy is very reliant on policy and technology. So even if individual people would like to adopt this technology, it is up to our policymakers to provide a national or even an international framework for the adoption of renewable energy. So what you see here are the top 10 countries of the world that are producing renewable energies. Those are the values in blue. But you have to take a look at their renewable energy generation side by their electricity consumption. So let's say, for example, China produces the most electricity from renewable sources. However, if you take a look at its energy consumption, only a small portion of its energy consumption comes from renewable energy. If you compare that to Brazil, Brazil is the third country that produces the most renewable energy, but its renewable energy production is very much comparable to its total electricity consumption, meaning majority of its electricity is coming from renewable energy. The same can be said for Norway. We are hoping for a future wherein all of our energy is coming from renewable sources. So with all of that being said, we conclude that sustainability is multidisciplinary. We need everyone's help and we need everyone's cooperation in order to live in a truly sustainable world. Of course, we chemical engineers are vital in the fight towards sustainability, but we cannot do everything. We must also rely on the expertise of other people in order for our world to be sustainable. And the takeaway is always rethink your actions if they align with our goals of sustainable development. I believe that with all of our little inputs, we can help towards our goal of maintaining a sustainable environment. For further reading on this topic, please inform yourself about the 17 Sustainable Development Goals set by the United Nations. I have given here the link to the list of the Sustainable Development Goals. This SDGs will give you an idea of the vast scope of sustainability and how it is not only centered on protecting the environment exclusively. You will see that the 17 Sustainable Development Goals covers all of the three dimensions of sustainability. And this is your first worksheet. I want you to calculate your ecological footprint This is the link, footprintcalculator.org. Answer the questions honestly and determine your personal Earth Overshoot day. Use your consumption data before the pandemic because our consumption data during this pandemic is lower than before the pandemic. So we want to get an accurate reading of your lifestyle before we had this pandemic. So let's go to the website. This is the website wherein you will be calculating your ecological footprint or your personal Earth Overshoot day. So you see that this is just a simple questionnaire. You will be asked how often do you eat animal-based products and other questions regarding your lifestyle. So please answer this honestly and then report back your ecological footprint and your personal Earth Overshoot day. I have done this before and my personal Earth Overshoot day is August 29. That is still very far from our goal of moving Earth Overshoot day towards December or towards the end of the year. So I am curious what your personal Earth Overshoot day is. Going back, the second is I want you to compare your demanded ecological footprint to that of the available. When I calculated mine, my ecological footprint is 4 global hectares, but the currently available footprint per person is only 1.7 hectares. That means that if I am requiring 4 and the Earth can only give 1.7, that means that I have a 2.3 hectare deficit. So that means that I am severely overshooting the resources of the Earth. Are you consuming more than your environment can provide? Explain in terms of the breakdown provided in the consumption category. In the consumption category, your consumption will be subdivided into food, transport, and other needs. So I want you to explain and explore those results. Number 3, what steps do you think can you do to lower your ecological footprint? This is a personal reflection on what can you change on your lifestyle such that your ecological footprint would be smaller. And last one, I want you to restart the calculator and input hypothetical values for a simpler lifestyle such as the following listed below. And you need to take note, how much did your footprint improve? Do you think we can push Earth Overshoot Day to a later date, preferably from October to December, if all the people on Earth would behave like you? And our terms for the simpler lifestyle are the following. That is lower meat consumption, fewer food miles, that is more locally grown food, less travels or commute, and modest housing with renewable energy. So I am encouraging you to explore this footprint calculator. Okay, that's it for this lesson. I hope you have learned something. If you have any questions, you can ask me through course messages. Please work on your worksheet and as always, keep safe.